Work on that worksheet 1. So if you did it on your OneNote, that's fine. Just pull it up on your OneNote. If you have it on paper, pull out your paper, whatever. Let's start with some questions from that. Does anybody have any that you want to talk about? Number 1? Sure. Hi, Miss Garcia. I'm right here on the ledge, exactly where you put it for me. You're welcome. All right. Oh, you can't even see what I'm... Somebody needs to tell me some of these things. All right. So number 1 asks us to find... That looked like it hurt. To solve for theta, where tan theta is equal to -1. First thing we do is we go and figure out on this interval, where are we looking on the unit circle, right? So if I go to my unit circle, let me grab a copy of that. If I'm starting at pi and going to 2 pi, we're looking in quadrants 3 and 4. Feel good, Ava? Yeah. Okay. And I remember that on the unit circle, my points on the unit circle are cosine comma sine. And then tangent is y over x. So if we have tangent is equal to -1, we have y equals x, or y over x equals -1, right? Or really y equals -x. So what I'm going to do is I'm going to search for, on my unit circle in quadrants 3 and 4, a place where the x and y coordinates are the same number, but opposite sign. So let's go ahead and go take a look. This appears to be the only location where the x and y coordinates in quadrants 3 and 4 are the same number, but opposite sign. We agree? So my value for theta should be 7 pi over 4. And the last thing I need to check is just to make sure that 7 pi over 4 lies between 1 pi and 2 pi. 7/4 is 1.75. That's definitely between 1 and 2. So 7 pi over 4 is definitely between 1 pi and 2 pi. So I am happy with this as my final answer. Nora? Certainly. Yeah, Reese. Yeah, sure. Okay. So again, we're going to want to start by figuring out what quadrant are we looking at, or quadrants, I should say. So we're going 13 pi to 15 pi. So we have we're starting here at 0. Then we have 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves, 11 halves, 12 halves, 13 halves, 14 halves, 15 halves. So I'm looking in quadrants 2 and 3. So far, so good? Everybody's okay with how I counted around to do that? And again, just trying to keep it simple. I'm just counting. I'm not trying to do anything fancy. So here we have cosecant theta. I remember that cosecant theta is 1 over sine theta. Right? So if I flip both sides of this equation, that's the same thing as saying sine theta equals negative 1 over the square root of 2. And if I rationalize that, denominator, I really am looking for where sine theta is equal to negative root 2 over 2. So I'm going to go back to my unit circle and look in quadrants 2 and 3 for the place, because we're looking for sine theta. I'm looking for y coordinates are negative square root 2 over 2. So if I look, this is the only place in quadrants 2 and 3. So my answer is going to be 5 pi over 4. Now I'm going to check to make sure that we're in here. So 13 over 2 is 6.5, and 15 over 2 is 7.5. 5 over 4 is 1.25. That's definitely not in between, right? So I'm going to add 2 pi. That's going to give me 3.25. Still not enough. I'm going to add 2 pi again. That's going to give me 5.25. Still not enough. So I'm going to add 2 pi again, and that'll give me 7.25. That'll do, right? So what am I going to do? I'm going to add 1, 2, 3. I'm going to add 6 pi to this to get my number. Sound good? So I'll think about that over 1. I'll make a common denominator, so multiply the top and bottom by 4 over 4. So 5 pi plus 24 pi is 29 pi, and the denominator just stays at 4. And that should do it. Does that feel okay? And again, like this thing that I did here to just figure out how many times I had to add pi, like how much easier does that make it if you just kind of ignore the fractions and drop the pi's and just worry about the decimal, just adding 2 a bunch of times? Like significantly simplifies that process for us. And again, like try to think about, if pi's and the fractions are getting in your way, like think about how to simplify it and be like, okay, I just need to make sure that this coefficient of pi is in between these 2 coefficients of pi. Can I turn everything into decimals? Sure. And just deal with it that way. And that's put it back as a fraction at the end and you're good. Yes, yeah. And so the Reese's question was, why did we add this time instead of subtract? Because we've subtracted sometimes, and it's because this number was too small. It was off here before 6.5, so I know I was going to have to add to it. If my number was too big, then we'd have to be subtracting the 2 pi's. Yeah. Which I think probably would happen on... Oh, maybe we don't have an example where that would have happened. No, it doesn't look like it. If one of these were negatives, then you would have to be subtracting 2 pi's if the intervals was 2 negative, or even 1 negative and 0 or something. Does that feel okay? Ava. Okay, which number what? Okay. I caught a mumble there and I wasn't, somebody crinkled at the same time you were talking and it was like just threw it all off for me. All right, so let's go first and figure out what quadrants we need to be looking at on our unit circle. So we're going from pi over 2 to 3 pi over 2. And at this point, I've probably done this one before. It's again going to be pi over 2 to 3 pi over 2. So it's again quadrants 2 and 3. Feel okay, Ava? Yeah? Okay. So if I go back to my problem now, cotangent, I remember as 1 over tangent. So if I flip both sides of the equation, that's going to be the same thing as where tangent is -1. Oh, we've done this problem before, right? We're just looking for where x and y are the same number but opposite signs. This time, though, we're looking at quadrants 2 and 3 instead of number 1, where we looked in quadrants 3 and 4. So the only place I see where that happens is here. So my answer should be 3 pi over 4. So as you're seeing, when we're doing this, literally there's really no work to even show, right? This is just, can you look up the number from the right spot? And maybe at the end, if you want to show some adding some fractions like we did on number 12, sure. But to generate like that 5 pi over 4, there's really no work that needs to be shown. So this is, ideally, these are pretty simple problems. Everybody's okay? Okay. You guys feel good with this skill? Okay. Because we're about to make this a little bit more difficult here. Decide what I want to do. I don't think I want to do any of that stuff yet. Yeah, we're not doing any of that stuff right now. What is that I want to look for? One moment. I just want to look something up real quick. All right. All right, here, folks. We're about to do a new, or the same problem, just we're going to start using our calculator to do this. Now, this is going to be a little bit more difficult than the problem that we just did, but it's the same type of problem. So there's not any new concept here. We're just going to see a new version of the same kind of problem we're doing. We're just eliminating the unit circle part and opening this up to being a calculator problem. So the way that I'm going to show you to do this is going to involve drawing some pictures and then using some sense about the pictures. So it's really important, the pictures that I'm drawing, you understand how I'm drawing this picture and are able to draw the same picture. Okay? It's not a difficult picture to draw, but the skill here, or what's going to make doing these problems as easy as we possibly can, is going to be able to draw the picture. Because I don't know about you, but I like having something to look at, right? If I can look at it and I understand what I'm looking at, it makes it really easy to understand and remember what to do. So I want to give you a really good, nice visual representation of what we're doing. So the first thing I'm going to do is try to figure out where I'm looking. So I'm going to draw myself like my standard position angle. So 0, pi over 2, pi, 3 pi over 2. So we're looking for quadrants 2 and 3, correct? Of course. Everybody okay there? I'm now going to eliminate one of the two quadrants and be able to say for certain which quadrant my answer is in. Bless you. So I remember, you guys remember we did we draw this picture and say like all silly turtles crawl? You don't remember this offhand? Okay. What this acronym is telling us is where our trig functions are positive. So A stands for all. All three, sine, cosine, and tangent, are positive in the first quadrant. S says that sine is positive in the second quadrant. T tells us tangent is positive in the third quadrant, and C tells us cosine is positive in the fourth quadrant. If it's not positive, then what would it be? Negative. So for example, in quadrant 2, where sine is positive, then cosine and tangent are negative. Everybody okay with that? What this acronym is telling us? So if I look here, I see sine is greater than 0. So I know that we're talking about either quadrant 1 or quadrant 2. Well, quadrant 2 is the only place where sine is positive and theta is between pi over 2 and 3 pi over 2. So that has to be where my answer is located. Is everybody okay with how I've ascertained that information? Really important that you're able to do this. So now I'm going to go ahead and draw my angle theta on that picture. So remember, theta is always going to be coming from the positive x-axis. And if it's a positive angle, it's rotating counterclockwise, right? Does it matter where I put that line in the fourth or in the second quadrant? Not a bit. I just wanted to draw it in there somewhere. Everybody okay so far? Still doing good? Okay. What I'm going to do now is I'm going to find this angle alpha. that angle alpha is always going to be between the terminal side of my angle and the x-axis. Okay, so I just wrote a little note for you guys that says alpha is always between, B/T is just an abbreviation for between, the terminal side and the x-axis. Right, that's where I've put that little alpha in our picture, right? So now let's look at what we can say about what our picture is telling us. If I take theta and I add alpha, that should get me to pi, right? Can everybody see that? Or really, I can say that theta is equal to pi minus alpha. Still doing good? So to calculate my alpha, we have the equation sine equals 0.37, or sine theta equals 0.37. We're going to do alpha is going to be the absolute value of sine inverse of 0.37. Most common mistakes students make is they put alpha between the terminal side and the y-axis. Mistake number one. Or they forget to do the absolute value when they use their calculator to do the inverse. So what am I going to be typing into my calculator then? I'm going to type pi minus absolute value sine inverse 0.37. I haven't typed it in yet, but this is what I wrote down, what I'm going to type in right here. So if you have your calculator with you and you want to follow along, I invite you to do so. So I'm just going to type the pi button by pressing second, and then that caret up arrow. You notice that's right there kind of underneath the down arrow. And then I'm going to write the subtraction symbol, not the negative. Make sure you write subtraction. And then to get the absolute value, I'm going to press Math and move over to the Number tab. And the first option there is ABS. That stands for absolute value. And then we'll do sine inverse of 0.37. Remember, to do sine inverse, you press second and then the sine button. So our answer here is 276 or thereabouts. We can check this though. You know, I want to see how to check this. What was the original equation? It says sine theta should equal 0.37, right? So if I do sine of that answer that I just got, I should get what number? 0.37. That's check number one. The second part is that number, 2.76, should be between pi over 2 and 3 pi over 2. Is it bigger than pi over 2? Yup! Is it smaller than 3 pi over 2? Yup! If you meet both those criteria, you're guaranteed to have the correct answer. Reese, is your calculator in degree mode or radian mode? Okay. My answer has to be in between, right? It has to be bigger than the small end and smaller than the big end, which I saw, right? 276 is in between 1.57 and 4.71, so I'm good. Okay? So all of these problems that we're going to do today require us to be able to effectively construct this picture here. What is this picture going to be telling us that we need to have? We needed that picture to get this equation. That equation will look different depending on your picture. Okay? So it's really important that we're able to build that picture correctly, because that's how we're going to get the equation to solve for theta. Is everybody okay? Let's do another example, eh? All right, let's walk through how we do this again. You guys ready? Yeah. All right, let's start by drawing our picture. The first step to drawing our picture is to figure out what quadrants this interval is covering. So 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, 5 pi, 11 pi over 2, 6 pi, ding, 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 13 pi over 2, and then 7 pi. So we're looking at quadrants 1 and 2. Reese. And notice how I've wrote as I was going around. I just updated what the label should be, right? And that'll be important in just a moment when we draw our picture, or finish drawing our picture. Now I'm going to look at the sign of the problem. I notice here that cosine is positive. So if I do all silly turtles crawl, cosine is positive at A and C, right? All and cosine, that's quadrants 1 and quadrant 4. our interval was quadrant 1 and quadrant 2. So where does our answer lie? In quadrant 1. Does everybody feel all right so far? Actually, let's do that. I'm going to change this problem slightly right now. Let's make this negative. Let's make this negative, just so we can see. That'll make the problem slightly more interesting for us here. So where is cosine negative at? Because we did positive already. What is negative going to mean? So quadrants 2 and 3, right? So far, so good? All right. Let's draw our picture now, or finish drawing our picture. So there's the terminal side of my angle in quadrant 1. So I have 1 time around, that's 2 pi. 2 times around, that's 4 pi. 3 times around, that's 6 pi. So there's my theta. Gosh darn it, guys. Well, where did I put the picture? Where should the picture be at? Quadrant. You dummy. There we go. All right. 1 time around, 2 pi. 2 times around, that's 4 pi. 3 times around, that's 6 pi. And then to my answer. So there's my theta. That's going to be my alpha. Always draw our alpha between your terminal side and the x-axis. Everybody's good? All right. So let's look at our equation. If I take theta and I add alpha, I should get 7 pi, right? And if we're looking for theta, then that's going to be 7 pi minus alpha. And what's alpha going to equal? I do cosine inverse of negative 0.92. But we're doing the absolute value of that, I should say. Absolute value of it. Do we feel okay? So let's type this in. 7 pi minus math, number, absolute value, cosine inverse, negative 0.92. And I get 19.25-ish. Yeah, Polly? Sure. Is your calculator in degree mode or radian mode, Nora? Should be in radian mode. If you didn't get 19.25.
Oh, it's 7 pi minus?
Yep, because we did, right, we had to get the theta by itself here. So you had to minus the alpha over, right? Sorry, I did that without saying anything.
So it's 7 pi minus absolute value. 19.25.
Yeah, now we're talking.
How did the little squiggly thing turn into 7 pi?
How did the squiggly thing turn into 7 pi?
Oh, no, oh,
This,
yeah, that thing.
that symbol is alpha.
Yeah. How did it turn into 7 pi?
It didn't. I looked at my picture and saw theta, and then if I go alpha more, that would move the terminal side right to the x-axis, which is at 7 pi. Right? So if I'm just looking at adding my angles, this angle plus this angle would move the terminal side straight to here, which is 7 pi. So I just said theta plus alpha equals 7 pi. Does that, and I figured that out from looking at the picture.
Yeah.
Right? I'm always going to get that from looking at the picture. That's why we need to draw the picture so we can get that equation correct. Now we've seen this equation be the same for two different problems. Let's look at another example here where the equation will be different. Sound good?
Yeah.
Okay. What's this, example C now? Yeah. Yes, Reese. I would get in the habit of checking, especially early on, but I don't need you to show me that because it's just something you're typing into your calculator, right? But I wanted to give you the tool so it's like, hey, I think this is right. Did I get it right? So you have a way to check it, right? So as you're doing your homework, you can check your answers a little bit and be like, I don't know what I was doing wrong on 7, but I couldn't get it to check out. You know what I mean? So no, I don't need you to show me that on your work, but I wanted to give you guys the tool to, you can check that as you're doing things. And that's nice to have on the test as well, right? There's really no reason to ever get one of these problems wrong without knowing you're getting the problem wrong, right? It's one thing to be like, yeah, I got it wrong. I don't know what I'm doing wrong, but I can't get it to come out. Versus, like, I've answered this, I think it's right. Well, you should know whether it's right or wrong before you turn in the paper. You know what I'm saying? Okay. So, again, we're going to draw our picture. So 0, pi over 2, yay, pi, 3 pi over 2. So our solution needs to lie somewhere in here in quadrants 2 and 3. Now I notice that tan is positive. So according to All Silly Turtles Crawl, that's either in quadrant 1 for all or quadrant 3 for the T. Which one is the overlap? 3. So I know that my answer here is going to be in quadrant 3. So let's draw our picture. And I'm just going one time around, right? Or no times, or just like straight to the terminal side. That's my theta. Does everybody feel okay?
What is the above quadrant?
A and S? Oh, that just says tan theta is greater than 0. I'm just observing where the tangent is positive for this problem, and that tells me the quadrants that I should be looking in. That's my messy penmanship there for you. Okay. All right, let's draw in our alpha. Where does alpha go?
No, between the 3, 5.
Between the x-axis and the terminal side. Always between the x-axis and the terminal side. Okay? Always x. Yes.
What was it called? Alpha?
Yeah.
That's between 5 and
The terminal side of our angle. Yes.
what's the terminal?
Well, you have the initial. That's the part that's frozen on the positive x-axis, and then you have the terminal. That's the side that's spinning around.
Okay.
When we talked about standard position angles. Is that?
Yeah.
Okay. All right. So what equation can we write now? So here's what I see.
Oh, pi.
Okay.
Or no, that alpha. I think I'm jumping ahead.
Nope, tell me. Just go.
I just said pi minus the absolute value and inverse of
So here's what I would say. Is theta covers both pi and alpha, right? If I look at my picture.
yeah.
So theta is going to equal pi plus alpha, right? Because if I take theta and I go to there, that's pi, and if I go to there, that's alpha. So pi plus alpha should give me theta. Does that, you guys see that?
Yeah.
So again, this is a different equation than we wrote before, right? Before we wrote theta plus alpha was, the axis, the x-axis label. Here we have theta is just the sum of those two things. So there's no algebra to do here. It's just ready to go to our calculator. So pi plus absolute value tan inverse of 156. We'll check this at the end. We didn't check the last one. I probably should have done that. So math, number, ABS, tan inverse 156. So that gives me 4.14. If I do the tangent of that number, I should get 156, which I do. And that number should be between pi over 2. Pi over 2 is 157. And 3 pi over 2 is 417, I think. Something like that, 4 something. Yeah, 471, I transposed the two numbers. But anyways, 414 is in between those, right?
Yeah.
So that is good. How do you guys feel so far? Okay, let's do one with negative interval, and that'll be our last example, and I think we can be done. This is the only skill I want to do today. Okay. So, once again, we want to start by drawing our picture. And the first thing that I want to do is figure out what quadrants are covered by our interval. Oops. So 0, notice these are negative numbers on our interval, so we're going clockwise this time. So there's negative pi over 2, all right. Negative pi, negative 3 pi over 2. So we covered those two quadrants. Then we notice that sine is negative. So if we do all silly turtles crawl, we get that sine is negative in quadrants 3 and 4. So where is our solution at? It's in quadrant 3 somewhere.
But how do we know where it's going to be from those two?
Okay, can you say that again with a fewer personal pronouns? What's it?
How do you know what quadrant it's going to be?
When
Based on those two that you the two quadrants.
Okay, so I knew that because sine is negative, we're in quadrant 3 or 4. And my answer has to be in quadrant 2 or 3.
Okay.
So the only place my answer can be is in quadrant 3 because it's the only place that satisfies both of them. That's what you need?
Yeah.
Perfect. Okay. So now I'm going to draw my angle. So there's my initial side. My terminal side is here. So there's my theta. Okay. Sure. Where's my alpha going to go? Between what two things? The x-axis and the terminal side. Yep. Which I think is what you're saying. I wasn't sure what we meant by the line, but that's okay. Now, the natural thing to say here is say, okay, well, theta plus alpha should equal negative pi, right? That's what the picture looks like. Here's the problem. Alpha is always a positive number because we're doing the absolute value to find it. But here, theta and negative pi are negative numbers. So it's not plus here, it's going to be minus, yeah. So we'd have theta minus alpha. Go to blue. Theta minus alpha should be negative pi. and I'll put that note in there, why we subtracted here instead of adding was because our theta was a negative value. Really, whenever theta is a negative number, you're going to have to like flip the operation from what it looks like it should be in the picture. Is that okay with everybody? Okay. So now it's just calculator time, right? And what did I say this was? Sine inverse. -0.42. Oops. So I have negative 271-ish. Let's check. So if I do sine of that number, we get negative 4 or 0.42, which is excellent. And I see that that number is definitely smaller than negative pi over 2. And it's definitely bigger than negative 3 pi over 2. So I know that I have the correct answer there. How do you guys feel? This feels all right? Great. Let's stop here. This felt like enough, right? An obvious continuation of the same skill we've been building on, but here we've added a little bit more complexity because instead of just being able to look up our answer from the unit circle and maybe adjust so that we find an angle coterminal to whatever the unit circle says so it fits in our interval, here we have to construct our own picture to figure out where this thing needs to be looking for, and then what do we have to add or subtract together to get the actual value inside of our calculator. So it's very similar skill, but like we have a little bit different technique for it. I'm going to assign at this point worksheet 2. And just for the sake of simplicity, since B-Day doesn't meet again this week, worksheet 1 won't be due this Sunday. It'll be due the following Sunday. So what is due this Sunday? Nothing, right? We turned in all of chapter 3 stuff already. These are the first of chapter 4, so nothing will be due because we won't worry about worksheet 1 until the next problem set. Nico? Did you get my thumbs up back? Okay.
No, I love the thumbs up.
It's like, yes.
It's like I looked. I saw stuff. I entered it. So yeah, so that's that's your guys's what you're responsible for this weekend, which is absolutely nothing. But please, 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 before we meet again, if you haven't done worksheet 1, please do worksheet 1. And if you, please, 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 before we meet again, do worksheet 2. Okay? These 2 skills that we're working on right now are really kind of foundational to a lot of ideas here that we're going to get to. So please, please, please make sure that we're kind of trying to stay on top of this, right? Yeah, I get it. It's been a long week.